Hello to everyone. This is Tarun. I'm from EC section. So today's my topic on network analysis is problem on sinusoidal response of a series RL circuit. So let us briefly discuss about how to solve the problem in series RL circuit. First of all, introduction to series RL circuit. A series RL circuit consists of a resistor R and the inductor L connected in series. The behavior of a circuit under sinusoidal input is crucial for understanding AC circuit analysis. So we all know that the resistor is the opposition to the flow of current and inductor is the energy stored in electromotive force. We will explore the fundamental concepts, equations and response of series RL circuit. So here we can see that the equation L into di by dt plus I into R is equals to V of t. So sinusoidal inputs are periodic signals described by sine or cosine functions. The general form of sinusoidal voltage input is V of t is equals to Vm sine omega t plus phi, where phi is the phase angle between the voltage and current. Vm, where Vm is the maximum voltage, where the omega is equals to 2 pi into f, where f is the frequency. The response of the circuit can be analyzed using phasors to simplify calculations. Here, impedance in RL circuits. Impedance is equal to the terminology of resistance, where resistor is used in the DC and impedance is used in the AC transients. Impedance Z is defined as the total opposition to the flow of alternating current. For a series RL circuit, impedance is given by Z is equals to R plus J by omega L, where J is the imaginary, omega into L, where L represents the inductor. The magnitude of impedance is calculated by mod Z is equals to square root of R square plus omega L whole square. So here let us discuss about the phase angle. The phase angle phi indicates the phase difference between the voltage and currents. So here we can see the phasor diagram of the voltage and the current. So it may leads or lags depending upon the elements present in a circuit. The phase angle indicates the phase difference between the voltage and current. It is calculated by using the formula tan phi by omega L into R. This angle affects how current lags behind the voltage in a RL circuit. So let us discuss the voltage and current relationships. The voltage across the resistor and the inductor can be expressed in terms of input voltage and impedance. The relationship is given by I of t is equals to Vm by sine of omega t plus phi, where I of t is equals to current with respect to time and Vm is the maximum voltage by sine of omega t plus phi, where phi is the phase angle. The voltage across the resistor and the inductor can be expressed in terms of the input voltage and the impedance. This demonstrates how current amplitude and phase are influenced by the circuit components. So here calculating the time response. The time response of the circuit can be derived from the phasor analysis of the sinusoidal input. The time domain expression for the current can be represented as I of t is equals to Im sine of omega t plus phi. This representation allows for the analysis of transient and steady state behaviors. So as we know, in steady state there are two behaviors of circuit, in steady state and the transient state. Here, energy storage in inductors. Inductors store energy in the magnetic field created by the current flow. The energy stored in an inductor is given by L square into R. Understanding the energy storage is essential for analyzing circuit behavior during transients. So, let us discuss about the frequency response. The frequency response of the circuit shows how the output current varies with the different input frequencies. At low frequencies, the inductor behaves like a short circuit, while at high frequencies, it acts like as an open circuit. So this is the very important point to solving a problem. At low frequencies, the inductor behaves like a short circuit, while at high frequencies, it acts like as an open circuit. This frequency dependent behavior is critical in filter design and in its applications. So here in example problem, consider a series RL circuit with the resistor 10 ohm and inductor 0.1 Henry. If the input voltage is V of t is equals to 5 by sine of 100 into t, calculate the current and phase angle. By applying the formula discussed, we can determine the circuit's response to this sinusoidal input. So, the summary and the conclusion of this topic is Series RL circuits exhibits unique sinusoidal responses characterized by impedance and phase angle. Understanding these concepts is essential for predicting the circuit behavior in AC applications. Further exploration of RL circuits can lead to the advanced topics in signal processing and control systems. So this is the brief clarification about my problem on series RL circuit. So thank you.